The requirements for using this methodology are quite straightforward. There must be discipline, a self-imposed patience and thoroughness. The original definition of the problem space must be correct. Each condition must have an exhaustive and mutually exclusive set of alternatives. Because of the completeness of the whole scheme, you can focus on each rule without any concern for any extraneous conditions and actions. Regardless of the order in which rules are reviewed, every one of them must be thoroughly inspected. What-ifs don't exist in this scenario. All situations will be covered. This methodology has been used in both large and complex system development projects and in small, simple tasks. Some of the problems solved were not IT problems. This pie refers specifically to IT projects. It has also been used as a method for structuring tests for large, complex systems. Prior to using decision tables for conducting tests, analysis showed that some situations were tested millions of times, while others were never tested at all. In one such situation, it was calculated that there were approximately 2.95 million possible paths through the program. A structured test, which tested every one of those paths, took less than 16 milliseconds on the large-scale computer for which the software was designed. A university project, which had been under development for decades, was moved to more modern equipment. The researchers required that the manufacturer of all the new equipment, computers, software and peripherals, use decision tables in planning the transition. The project used decision tables for all its own software and hardware interfaces, and the whole new setup ran the first time it was fired up. This is how my pie of the projects for which the methodology was used breaks down. Most of the time was spent drawing up the tables, redoing them and refining them until a satisfactory partitioning of the solution was achieved. Because of the high degree of confidence in the outcomes, it was possible to use some very special tricks that needed careful documentation. This too was a significant portion of the effort. And then of course there was the time to actually code the solution. Debugging was a trivial linear process. The rules were tested methodically, one at a time, until one failed. At this point the test was halted and a dump that identified the failing rule was output. It included the expected outcomes and the actual outcomes. One quick look at this dump and it was possible to pinpoint exactly where the code didn't conform to the table. Because the testing was so rapid, we didn't pare the number of tests down after each dump. We simply ran the whole lot over again. Each iteration brought us closer and closer to completion. When we made it all the way through to the end, we were done. This also served as a sort of a regression test, since if some change caused an earlier rule to fail, we would know immediately. And this concludes this presentation. I invite questions and comments from viewers.